Let's start the homework video guide on algebra review. So for question number 1, we just need to simplify the following problems. So I see a plus sign right here. So I have 3x squared y, and we can combine that with 2x squared y. So we're simply just adding these terms right here because these are like terms. So 3 plus 2 is going to be 5. So 5x squared y. And then we have our positive 4xy squared, and that will match up with the positive 5xy squared. And we're simply just adding the coefficients there. So 4 plus 5 is going to be 9. So 9xy squared. So we're simply just adding the coefficients in this first problem. For part B, we have a classic distribution FOIL question. So 2x times 5x is going to be 10x squared. Okay. And then we take our 2x and we multiply with a positive 1, so that's going to be positive 2x. Okay, and then we take our negative 3, and our negative 3 will multiply with the 5x, so that'll be negative 15x. And negative 3 times positive 1 will be negative 3. Okay, and then from there we want to combine our like terms there, so I have my positive 2x and my negative 15x, so we have our like terms there. Okay, so negative 15 plus 2x is going to be negative 13x, and then minus the 3. And there's our final answer for that question. Let's move on to the next distribution question. So we have the classical question where I give you a fraction as a leading coefficient, and this whole term here in yellow will be distributed into the brackets. Okay, so one thing that you might want to just kind of focus on here is this coefficient of 3/4, and we want to multiply that with this coefficient of positive 4. And usually what I normally do is I take my denominator here, which is 4, and then I look at this number over here, which is also 4. I just divide those two numbers, so 4 divided by 4 is going to be 1, and then 1 times 3 is going to be 3. So my coefficient there is going to be a 3 to start. Okay, and then I have my x squared times my x, which will be x cubed. And then I take my y cubed times my y, which will be y to the power of 4. So that's how you distribute the very first term into, that's your first distribution step. And then on your second distribution step, you want to distribute this with this now. And once again, my bottom number here is a 4, and then I have a 16, right? So 16 divided by 4 is 4, and then 4 times the 3 is going to be 12. So I have positive 12 there. Okay, so that technique will come up a few times in this homework video guide. X squared times x to the 3 is going to be x to the 5. And then finally we have y3 and y5. So if I multiply those, we just add the power. So 3 plus 5 is going to be 8. So there is your final answer for that particular question. Let's move on to question number 2, where we need to solve for x. Now for this particular question, I noticed that there's a 2 on the denominator, and if the numbers on the denominator were dividing by 2, right? So to undo that, we need to multiply by 2. So I'm going to multiply, I'm going to take this 2 and I'm going to multiply that with the 7 on the right hand side. So 7 times 2 is going to be 14. And then on the left hand side, I have 3 bracket x plus 3, and then the minus the 4. So as you can see, the downstairs 2 has been moved to the right hand side by multiplying by 2. And then from here on, you can just distribute. So 3 times x is going to be 3x. 3 times 3 is going to be 9. And then minus the 4, and that's going to equal to 14 on the right hand side. From here on, I would just collect like terms there. So 9 minus 4 is going to be 5. So 3x plus 5 equals to 14. Okay, and then we have a positive 5 here, so if I want to move the positive 5 to the other side, I need to subtract both sides by 5. So we're going to just subtract the 5 here, so 14 minus 5 is going to be 9, and then from here on you can just divide both sides by 3, and your final answer here should be x equals to 3. Okay, let's move on to the next solving for x problem here. So I have a positive 5 on the left hand side. If I want to undo that, I need to subtract 5 from both sides. Okay, so if I do that, I got my 2/3 x on the left hand side, and 7 minus 5 is going to be positive 2. Okay, then there's a 3 on the bottom here, so very similar to the first question. If you're dividing by 3, that means, if the 3 is on the denominator, that means you're dividing by 3. So the opposite dividing is multiply, so you want to multiply this side by 3. So 2 times 3 is going to be 6, and that means you just had the 2x on the left-hand side. And then from here you can divide both sides by 2. 2's cancel, and x would equal to 3. Okay, so there it is for that question there. All right, so for question number 3, I need to write in the form y equals to mx plus b. It says graph, but we're not going to graph this, and we want to identify the slope and y-intercept. Okay, so here we go. I noticed that there's a 3 on the bottom there, right? So if we're dividing by 3, if you want to undo that, you need to multiply by 3. So if I multiply the right-hand side by 3, the 3 can just come over here. Okay, but you're multiplying the entire right-hand side by 3, okay? So the 3 is on the left-hand side. You can move to the right-hand side by multiplying it, but you have to multiply everything on the right-hand side by 3. And the way we show that is by showing the brackets. Now we can distribute this. So this will be 3x plus 12. Okay, and then finally we can divide both sides by 2. And we'll notice that the 2's cancel here. So now I have y equals to 3 over 2x plus 6. Okay, and then from here on, we know the slope here. The slope here is going to be 3 over 2, and the y-intercept is going to be 6. All right, so that's it for that question there. We need to identify the slope and the y-intercept. Okay, moving on to the next one here. Here's another question where we need to identify the slope and y-intercept. Okay, I have 2/3 here, and I need to distribute that into the brackets there. So I would take my 9 here and divide that by 3 first. So divide first. So 9 divided by 3 is going to be 3. And then 3 times the 2 is going to be 6. So this will be 6x if you distribute that. Okay, so we need to distribute this 2/3 onto the 9x. That gives us 6x. And then I need to distribute the 2/3 onto the 15. Okay, so I take my 15 and I divide by 3. So 15 divided by 3 is going to be 5, and 5 times 2 is going to be 10, so plus 10. Okay, and then we just distribute this -3 into the bracket, so this will be -3y, and -3 times -1 will be +3, and that will equal to 10. Okay, from there on, let's see if we can collect some like terms here. So I have my 6x. I have a -3y. 10 plus 3 is going to be 13, equals to 10. Okay, and then notice that there's a +13 here, so I can move that to the, I can definitely move that to the other side. And if I want to move that to the other side, I need to subtract by 13. So if I just subtract by 13 here, I get -3. Okay, and then I need to move the 6x to the other side now. So this will be -3y. Equals to -6x, and then the -3. Okay, we're getting very close here. Final steps here are we want to divide by -3. Okay, if we do that, the -3's cancel here, so I get my y here. So y equals to, and -6 divided by -3 is going to be 2, so this will be 2x. And then finally, we have a -3 divided by -3, which should be +1, right? So negative divided by negative is positive. And then from here, you should see that the slope is going to be 2, and the y-intercept is going to be 1. All right, so that satisfies that question there. Okay, let's move on to the next question here. Question number 4, write an expression for the shader region in simplified form. So the shader region is pretty much this gray region right here. Okay, so it looks like we need to find the area of the bigger square, which is 2x plus 1 times 2x plus 1. So let me write that down. Area is really 2x plus 1 times 2x plus 1. That's length times width. And then I guess we need to just subtract this inside square there. So this is the length and that's the width. So length times width is x times x, which is x squared. So I need to subtract x squared. Okay, so the area of the shader region is this expression right here, and we just need to simplify this. All right, let's FOIL this. So 2x times 2x is going to be 4x squared, and then 2x times 1 is going to be +2x, and then 1 times 2x will be +2x, and 1 times 1 will be +1, and then we subtract our x squared. Okay, and then from here on, we just need to simplify by collecting like terms. So I have a 4x squared and a -x squared. So those are like terms because they both have an x to the power 2. So 4 minus 1 will be 3, so 3x squared. And then 2x plus 2x will be 4x. And then the positive 1 there. Okay, so that right there is a simplified answer for the shaded region there. Okay, let's go on to the next one. Trig review, question number 5. If tan theta is 2/3, then estimate 2 possible angles which theta can be. Okay, so we know that tan theta, let me write this out again. So we know that tan theta is equal to 2/3. And we learned in the last lesson that 2/3 is really the slope. So this is your rise and this is your run. Okay, in order to find our angles here, we just need to draw a line that has a slope of 2/3 from the origin. Okay, so here's the center of my circle, and from that center we need to create a line that has a slope of 2/3. So we go up 2 and we go right 3. All right, so that's my first point there. So that's that has a rise of 2 and a run of 3, and then we just continue this pattern, right? So we go up 2 and over 3. Right, so it turns out that once I draw my fourth once I draw this dot here, I go outside the circle. So now I can stop, and now we can go backwards now, and we can continue the slope of, down to left 3, down to okay, and then we go down to that. Okay, so right there, that's my slope of 2/3. And what we're going to do next is we're just going to draw a line connecting all the dots here. And we're going to do our very best to approximate the blue dots. Okay, so those blue dots, that's pretty much basically where the angle is going to be, right? So theta is exactly like just right here, and our other theta is going to be right down there. So theta is going to be those two angles there. Okay, so I'm kind of erase the green line a little bit here. And the goal is now we want to find those the blue dots. What do they equal to? Okay, well this is going to be 0, this is 10, this is 20, this is 30, this is 40, this is 90, this is 180, this is 190, this is 200, this is 210, 220, 230, 40, 50, 60, and this is 270. Okay, so if I had to go ahead and just draw my line here, it looks like this first angle, you know, this angle is going to be roughly 30, maybe about 30, maybe 32 degrees, roughly. And then if I just draw this down there, I mean, this angle right here seems to be about, I don't know, 212, maybe 212 degrees. Okay, so those are all approximations here, right? So 212 degrees and 32 degrees. Those are very good estimates. If you go to a calculator, I'm sure you'll be within like 1 or 2 degrees. So that's a very good way to kind of estimate what those two angles could be, given that your tan theta ratio is a fraction is 2/3, all right? So we're going to find the two angles that will give you a ratio of 2/3. So what we're trying to say here is if I give you tan 32 degrees, this will be roughly 2/3. And if I use my other answer of tan of 212 degrees, if you put this into a calculator, you will also get a ratio close to 2/3. Okay, so that's it for that question. Now let's move on to question number 6, where we need to find the LCM and GCF of the following here. Okay, so I'm going to start off with the GCF. And a lot of these kind of problems, you can kind of look at the problems and expect the variables and just jump to the final answer here. Okay, so let's take a look at the x variables. Okay, I have an x and an x squared. So the greatest common factor, the greatest number of x's that I can remove from x and x squared is just a single x. Okay, and then if I take a look at my y's, I have y of 4 and y cubed. The greatest number of y's that I can remove from y to the 4 and y to the 3 is just y to the power of 3. Okay, I can remove a maximum of 3 y's from y to the 4 and y to the power 3 at the same time. Okay, so there's your GCF, xy cubed. And now for your LCM here, least common multiple, the first multiple that comes up here. Okay, well I have an x squared and an x, right? If you think about this, x and x squared, there's your single x and there's your x squared. The first multiple that has to come up is going to be x squared, right? So it's going to be x squared. And then if I take a look at my y4 and y cubes, the first multiple that comes up between y to the 4 and y to the cubed, if you think about this, the y cubed is kind of like that, 3 y's, and y to the 4 is 4 of them. So the first time, the first multiple that will come up is when we have another y there, and our first common multiple there will be y to the power of 4. Okay? Okay. So before we kind of move on with the rest of the questions, let's kind of summarize how we can quickly find the GCF and LCM here. Going back to the GCF, you look at your x's, right? When you're finding your GCF, you're just taking the variable with the smaller power. So which one has the smaller power? Is it x or x squared? Well, it's a single x, right? If I look at my y to the 4 and y cubed, which one's smaller? Is it y to the 4 or y to the cubed? Well, it's y cubed, right? So when you're finding your GCF, you're just finding the variables with the lower powers. And in reverse, if you're looking for the LCM, you're looking for the variable with the higher power, right? So which is the higher power? Is it x or x squared? Well, it's x squared, right? And for y to the power 4 and y to the power 3, which one has the higher power? Well, it's clearly y to the power 4, and that's why your LCM is x squared y to the power 4. So that's a very quick way where you can find your GCF and LCM by inspection. Okay, this next question, there's a few more numbers in this one. So GCF. Okay, so look at the 12 and the 30. What is the biggest number that divides into 12 and 30 at the same time? Well, the biggest number that divides into 12 and 30 is going to be a 6, right? So 6 can divide into 12 and 6 can also divide into 30. So your GCF for 12 and 30 is going to be 6. And then for your a cubed and your a squared, which one's smaller? Is it a cubed or a squared? Well, a squared is smaller. Okay, now for your least common multiple, now you got to think a little bit harder here with the 12 and the 30. The least common multiple between 12 and 30 is going to be 60, right? So if I take my 30, if I multiply that by 2, if I take my 12 and multiply by 5, 60 is the first common multiple. All right, and then ask yourself which one's bigger. Is it a cubed or a squared? Well, a to the power of 3 is clearly bigger, so the least common multiple is 60a cubed. Okay, let's move on. Okay, let's find the GCF here. Okay, so look at the 4 and the 8. What's the biggest number that divides into 4 and 8 at the same time? Well, that's going to be 4. And then look at the variables. Which one is smaller, x to the 4 or x to the 3? Well, it's x to the 3. And then for our least common multiple, okay, so look at the 4 and the 8. What's the first multiple that what's the first common multiple between 4 and 8? Well, if I look at my multiples of 4, I have 4, 8, 12. My multiples of 8 are 8, 16, 24. Clearly, the first multiple is going to be 8. Okay, and then which one has the higher power, x to the 4 or x to the 3? Well, it's going to be x to the power of 4. Okay, let's keep on going along. GCF here. The biggest number that divides into 9 and 3, 3 and 9, well, that's going to be 3. 3 is the biggest number that divides both 3 and the 9. It turns out that there's no common variables, so that's it for the GCF. For the least common multiple, well, what's the first multiple between 3 and 9? Well, the first multiple that comes between those two numbers is going to be a 9. And then since we have all single variables here, we just attach them, right? The biggest number of R variables is 1R. The biggest number of S variables is 1S. The biggest number of T variables is 1T. And then we have our X, Y, Z. So that's our least common multiple. Okay, let's keep on going. A few more to go here. Now I have a negative 9 and 18. So our GCF, the biggest number that divides into negative 9 and 18 at the same time is going to be positive 9. And then look at my p's and p squared. The smallest number of p's is a single p, and the smallest number of q's is a single q. And for our least common multiple, well, the first multiple between 9 and 18 is actually 18. And then ask yourself, what's bigger, p or p squared? Well, p squared is bigger. And what's bigger, q or q cubed? Well, q cubed is bigger there. Okay, so that's it for that one there. Look at my 8, 9, and 6. Well, the biggest number that divides into 8, 9, and 6 is going to be 1. And then look at your A's. What's the smallest number of A's that we have there? Well, it's just a single A. And the smallest number of B's is a single B. So 1AB is your GCF. And for least common multiple, least common multiple here, we've got to think a little bit. So 8, 9, and 6. So the first multiple of that is going to be 72. So this will be 8 times 9 will give you 72. And 9 times 8 will give you 72. And 6 times 12 will give you 72, right? So 72 is the first common multiple for 8, 9, and 6. And then from there, the variables are easy. We always take the biggest variable here. So the highest number of A's is A squared, and the highest number of B's is going to be B squared. And that's it for that one there. Okay, next one here, since they all have negative signs here for their GCF, -2 is the biggest number that divides into -2, -4, -4. And then take a look at the x variables, right? Which one's the smallest? Well, it's going to be x squared. And then look at your y variables. Which one's the smallest? Well, it's going to be a single y. And for our least common multiple, if I go back to the numbers, -2, -4, and -4, the first multiple that comes up with all three numbers is going to be a -4. And then we take the highest, right? So the highest here is going to be x cubed. And our highest here will be y to the 4. Y to the 4. Good. All right, last question here. 10, 16, and 20. The biggest number that divides 10, 16, and 20 is going to be, I think it's going to be 2, right? I think 2 divides all three of those numbers at the same time. So GCF will start with the 2. And then a single x, right? So all of them have a single x. And that's it. They don't share any more common variables, so that's it. For the least common multiple, 10, 16, and 20, the least common multiple between those three numbers should be 80. All right, so 20 times 4 gives you 80. Obviously, 10 times 8 gives you 80, and probably 6 times 5 will probably 6 times 4 maybe. Sorry, just correcting my math here again. It should be 6 times 5 will give you 80. Okay, so the least common multiple is going to be 80. The maximum number of x's is a single x. The maximum number of y's is a single y. And the maximum number of z's are a single z there. Okay, so that's it for this homework video guide.